Hi, this is Mr. Adams from Middlebury High School, and this is a video on writing ester structural formulas. Before we move on, I previously said in the previous ester video that you can think of the reaction as H plus and OH from the alcohol, right? But in this experiment right here, they actually label the oxygen with the isotope of regular O16, O18 oxygen, and it seems as if the H comes from the alcohol and the OH comes from the acid. Now, either way, folks, that doesn't matter to us because when you go to college, you'll figure out where, that later on. All we're concerned about is that we have an acid reacting with the alcohol to give us a ester. So either way, we're okay. All right. Now moving on. When you're actually given a name, right? Okay, and you have to write the structure, you must understand that the parent name came from the acid. And in terms of the parent name, we are referring to the name that's in the back right here. Okay, alrighty. And the branch name came from the alcohol. Now, it's always a branch. Okay, always has a YL ending from experience. Okay, so we must remember that's telling us the number of carbons that came from the alcohol, and the alcohol will be only single bonded to oxygens. All right, so this is the first example. We have propyl methanoate. All right, now let's go with this first. We have methanoate. We know that came from the acid, so it came from methanoic acid. So we're going to write one carbon down because the prefix for meth is 1, right? Then we're going to put C double bond O. Okay, we're going to put an H on this side, all right, and a double bond O on this side. Okay, so that's originally methanoic acid would have another H right here. But since it's an ester, right, it doesn't have an H there anymore. It has some number of carbons. And how many carbons does it have attached to that single bonded oxygen? The name propyl, prefix prop, tells us. Prop refers to 3. We put 3 carbons. 1, 2, 3. We put our hydrogens in carefully, and we're done. Okay, so that's propyl methanoate. This part refers to propyl or propyl, and 1 carbon right here. Okay, with the C double bond O. COO group, the double bonded O and the single bonded O, refer to the acid part, and you're done. Okay, the next one is the same way, alrighty. Okay, all we're going to do is look at the ending, the parent. It says pentanoate, right? And from experience, we know pent refers to 5. So originally, we had a 5 carbon acid. So we're going to 1, 2, 3, 4, 5, right? Okay. And it has a double bond O right here, okay, and O right there. So that's the acid part. Now, once again, it would have had a H right here for the acid, but it's not an acid anymore. It's an ester. How do I know it's an ester? Because of this ending right here, O8 ending, all right? And if you're not sure, use table R. Look at it. They show you how to write structure formulas. It shows you how to do the endings. So do a matching to see which particular functional group you're dealing with. Don't just guess. And how many carbons are attached to that single bonded oxygen? I know there's 4 because but is my prefix over here in terms of the alkyl name. So I'm going to put 4 carbons. 1, 2, 3, 4, right? I put my hydrogens in carefully. Okay, now once again, I'm leaving the H's out just for the sake of space and time. But typically on a test, you should write your lines and write your hydrogens in, okay? Because you're not going to have a whole bunch of these structures to do. Okay, and you're done, all right? So that was propyl methanoate and butyl pentanoate. Esters are pretty interesting. Once again, they're used widely in industry for perfume and flavorings and all kinds of stuff like that. And there you go. Okay, as always, hard work plus sacrifice equals success. I hope this video was a help. Take care.